Good morning, everyone.
Good morning.
Any questions in the last session? Okay. So today we will see the VPC slides and then a database services followed by a lab. If time permits, we'll also cover Route 53. Okay. Let me share my screen. Networking. We will cover different concepts in networking, not only that we covered yesterday. Okay. So I want you to be a little patient today because we will be covering a lot of theoretical topics. Okay. So you have any disturbance from my end? That fan sound is disturbing you?
No.
No. Okay, perfect. VPC. So we learned that VPC is like a network and it is isolated within the account. Okay. And whatever the components which we create in one VPC can't be seen from other VPC. They are isolated. Okay. And we can have resources, AWS resources in VPC like the instances, the security groups, route tables, subnets. These are called the resources, or we usually say VPC components. The components which are inside the VPC. Okay. And VPC spans all availability zones within the region. Okay. Now, can I have a VPC in two regions? A same VPC cannot be there in two regions. Okay. So VPC is region specific. When it comes to subnet, it is availability zone specific. When you are creating a subnet, you might have observed that you are creating a subnet in an availability zone. Okay. Now, when you create a VPC, we define a CIDR, a network ID. Okay. So that particular CIDR is called a primary CIDR. Yeah. Now, understanding the difference between default and custom VPC. Default VPC is a VPC which is created by AWS. And custom VPC is the one which is created by the customer. Which is created by the customer. Okay. Now, usually we cannot delete default components. Okay. So, for example, if you try to delete a security group, it doesn't allow us. There is a way where you can delete VPC, default VPC, but that is not recommended. So it's like this. Let's assume we have a default VPC. We have a custom VPC. If you create a security group, for example, in default VPC, because it's you created, it's a custom security group. In custom VPC means which we created. If AWS created a security group, because it is AWS created, it's a default security group. Now, what I want you to understand here is, irrespective of whether it is a default VPC or a custom VPC, if you create any component, it becomes custom. If AWS creates any component, it becomes default. Yeah. Now, in default VPC, all subnets are public subnets only. Means all the subnets are associated to a route table which has internet gateway as a route. You see, internet gateway as a route. So all subnets are public subnets. That is the reason when we tried to launch an EC2 instance and connect it, by default we are able to connect it because all the subnets are public subnets. But when it comes to custom VPC, see, by default, when we create a VPC and create subnets, they are private subnets because internet gateway component is the one which we created in the custom VPC. By default, it is not created for us. So AWS follows RFC 918 standards where you can go for any one of these ranges. Okay. But explicitly in AWS, we can go from /16 to /16 to /28. Okay. Now, if I have a VPC with this CIDR, you can have a subnet with the same CIDR. Yes, possible. Possible. That means your subnetwork is taking all the IP addresses from the main network. That means you furtherly cannot create any other subnets. Obviously, right? Because the IP addresses, the subnet 1 has taken all the IP addresses from the main network. And you cannot create any other subnets after this. Even though it is not recommended unless your VPC is very small, then yes, you can go for the same CIDR as your VPC for the subnet. Okay. Now, if you have two different subnets, another scenario. So let's assume I created a VPC with this CIDR and I have two subnets. Subnet 1, subnet 2. Now, when you're having two subnets, these subnets should not overlap. When I say overlap, you cannot have same IP addresses for two subnets. Okay, it's like a class of 50 people. It's a class of 50 participants. There are two groups which are divided, group 1, group 2. And then 25 each. Now you can have a roll numbers from 1 to 25. And here you can have a roll number from 26 to 50. Now when you're creating two groups, they should not overlap. Means a person cannot have a same roll number in two different classes. The same way, because you're talking about creating a network, okay, creating a subnetworks in the main network, okay, so these subnets should not overlap. You cannot have an EC2 instance I mean to say two EC2 instances in two different subnets with the same IP address. Not possible. It should not overlap. So what happens if it overlaps? Basically, AWS will not allow you to create a subnet itself if it is overlapping. It just says that it is overlapping kind of error message. We should keep that in mind. Now, in our scenario, first subnet IP addresses are all starting with 10.0.1, whereas second subnet IP addresses are starting with 10.0.2. They're not overlapping. Now, in each and every subnet, we understood that in each and every subnet, let's assume this is a subnet. Now, if you can write the combinations of IP addresses, 10.0.0.0, 0.1, because we have forward slash 24. So first three octets would be of subnetwork prefix. And you have only one octet for hosting. So 0.1, 0.2, 3, so and so forth, 0.255. And we learned that the first four IP addresses and the last one is reserved by AWS. So the first one is for network address. Second one is for the VPC router. Third one is for the DNS server. Fourth one is for the future use, if in case AWS wanted to use it in later point. And the last one is for the network broadcast address. So please understand, in each and every subnet, you will have 5 reserved IP addresses. You should be really careful when you're actually choosing the subnet. Okay, if you need 256 IP addresses, for example, you cannot go for this CIDR, isn't it? Ideally, you may get 256 IP addresses, but you can use only 251 IP addresses. So you may need to go for a bigger one. Oh yeah?
Yeah, but yesterday, Anupama, we could able to create the 10.0.0.4 slash 24.
Correct, ma, we can create it. I never denied
But it
it.
is not recommended. That is exactly. The moment you said it is already reserved by AWS, so it is not recommended to have 10.0.0.1 to 123, right? I mean, apart from
No,
that,
no,
it
it
should
is
have
not. It is not recommended.
okay.
AWS will reserve it automatically. If you take your EC2 instances, the EC2 instances will not have any one of these IP addresses.
Okay. Okay.
Hmm. Now, let's assume I have a VPC, and VPC is having a CIDR of /60. Okay. Now, how many IP addresses we can get if we go for this CIDR? Around?
It would be, yeah, 65,000 around.
Exactly. Now, let's assume I have utilized all the IP addresses, created multiple subnets. There are thousands of instances. So mine is such a great architecture. So I have utilized all my IP addresses. Now, if I want furtherly, this is the max I can go, right? /16 is the maximum I can go. Now, what if I
Correct.
need
Correct.
furtherly? I can go for secondary CIDR for the same VPC. So this is primary. Now I can say 10.0.1.0.0 Now the primary and secondary should not overlap again. Now all the IP addresses in the primary CIDR data starts with 10.0. In the secondary CIDR starts with 10.1. They're not overlap.
Okay, got it.
Okay. Now another thing is, let's assume I created a VPC with 10.0.0.0 /24. I created a VPC itself with 24. That means the 3 octets would be of network prefix, and I'll have only 1 octet for hosting for the whole network. So I will be getting 256 IP addresses for the whole VPC. Now initially I need only few IP addresses, so I created with this CIDR. Now later, I want to go for more IP addresses. I expanded in future. Can I change the CIDR of a VPC? No, not possible. Okay. Now, once you create a VPC or a subnet, you cannot increase or decrease the range. So you have to be little wise in creating the VPC in the first hand. Okay. Now, understanding the public and private subnets. If a subnet is associated with a route table which has internet gateway as a route, then this subnet will become public. If a subnet is associated with a route table which doesn't have internet gateway, becomes private. If a subnet is associated with a route table which has NAT, then also it is called private. Okay. So as I said, even in the exam, certification exam or any interviews, if they want to test you, okay. So maybe in the test, they will tell that public and private subnets. Okay, so then you should understand a public is having an internet gateway, private is not having internet gateway or having a NAT. Okay, so if they're having a NAT, they will explicitly inform it that okay, there is a NAT for the private subnet kind of. Next, we have VPC flow logs. Now, yes, I have thousands of instances. Now I'm trying to reach an instance from another instance. I'm not really sure where that request is going. What you can do is you can go and enable the VPC flow logs. Okay. So the VPC flow logs will capture the IP traffic flow. Okay. Will capture the IP traffic flow which is happening within the VPC. Okay. Now, these logs can be stored in CloudWatch. So we have a CloudWatch logs, and these VPC flow logs use CloudWatch to store the logs. Okay. Now, if you wanted to know the IP traffic flow within a subnet also, you can do it. You need not enable for the whole VPC if you don't want to. Now, security group. We learned about security group, right? That it's a firewall, for instance. It's a stateful, and we can only allow rules. Okay? And it is used to control who can access the EC2 instance. Why we have a slide again on security groups? Because there is another firewall, which is NACL. So this is an optional layer of security for your VPC. Okay, it's like this. You have an EC2 instance. Okay. So the instance of firewall is what? Security group. Now, the EC2 instance will be in a subnet. Okay. Now, NACL is a firewall for your subnet. So multiple layer of authentication, or we say a layers of security. Now, if I allowed in security group, but not allowed in NACL, it will not allow. If I allowed in NACL and not allowed in security group, it will not allow. So it has to allow as security group as well as in NACL in order to reach the EC2 instance. Okay. Now, if you see in terms of like now I see if I need to connect to the EC2 instance from my local machine. When I am making a request, if you see in terms of EC2, it's incoming to EC2. So it has to first of all cross the NACL borders and then it has to cross the security group borders. So both inbound only. Inbound for security group, this is inbound for NACL. Now when EC2 instance is responding, it's going out. Outbound of security group and it has to furtherly go out of NACL also. So outbound of NACL. Okay. Now if you are seeing from your local machine, NACL is the first level of firewall and security group is the second level of firewall. But if you see from EC2 instance, when EC2 instance is trying to reach or give respond, security group is the first level of firewall, NACL is the second level of firewall. Okay. Now, even though NACL is an optional layer, it is recommended to use the NACL when you're deploying your applications on EC2 instances. Okay, because it acts like another layer of security, isn't it? So if you have your data and the data is very sensitive or very important, obviously you will try to enable as many as layers of security. Okay. Now let's understand the difference between a security group and NACL. Okay. So we know that security group is a firewall for EC2 instance and NACL is a firewall for subnet. And security groups are stateful because if you allow in inbound, it allows in outbound also. Okay. Whereas NACL is stateless. If you need to allow a protocol in inbound, you have to open the protocol in the outbound as well. But in security group, if you allow in inbound, it automatically opens for outbound. So NACL are stateless. In security groups, we can only allow rules. We cannot explicitly deny. There is an implicit deny, but there is no explicit deny. But in NACL, we can we can allow as well as deny. We can allow or deny. You can explicitly mention whether you wanted to allow the traffic or deny the traffic. Okay. Now let's understand few rules. So how to basically when you have rules, how to evaluate. Okay. Now in NACL, because you have allow and deny, you define the rule numbers. For example, I say 100 and uh, a TCP type, SH protocol, port range of 22, everyone, and I'm allowing it. Now I have another rule, TCP protocol, TCP type, SH protocol, port range of 22, and I say everyone. This time I would say deny. This time I would say deny. Now, will it allow or deny? Because in the first rule, I said everyone allow. And in the second rule, same protocol, same type, everyone deny. Now, if you have if NACL faces this kind of rules where it is overlapping, same range of IP addresses are allowing in one rule and then denying in another rule. Now, NACL works on the ascending order. Okay. Now, first come first rule. First come first rule basis. It's like this. Now, because you said 100 allow, it will just go and allow it. Even if you have deny later, it will rule off. Okay. Now, what if I have numbers like this? 110, 100. Now, because the least number is saying deny, it will just go and deny. It will rule off the allow rule. Okay. Now, basically, if there are some set of IP addresses which are overlapping, then yes, it works on the rule number based. But ideally, no one will give rules something like this, right? So ideally, the rules would be like this. So if you have rules the way which I'm going to explain, you need not worry about the rule numbers here. Yeah. Now, I'm saying 100 and then I say 1.2.3.4 allow because this is my client machine IP address. And then I'll say 110 and I can say something which is harmful to my machine. I got that IP address and I'm mentioning here as denied. Now, whether you have 100, 110 or 110, 100 doesn't matter. This will allow and this will deny because they are two different IP addresses. They are not overlapping. If they overlap, then yes, you should be thinking of rule numbers. Okay. Route tables. So when I say default VPC, I said that a default VPC is a VPC which is created by AWS. Now, when AWS creates a VPC, AWS creates default subnets. AWS creates a default route table, which is called as main route table. AWS creates a default internet gateway. It creates an NACL and it also creates a default security group. Now, when we say AWS create AWS VPC or a default VPC, it creates all these components so that when you're starting with AWS, you can straight away start with any of the services. You need not start with VPC because without a VPC, you cannot have an instance. If you observe, from the day one, we have created a lot of instances, but none of the instances created without VPC. Correct? So knowing or unknowingly, we have created in VPC only. Now, if a VPC is not being created by AWS, first of all, you need to learn about VPC, create it, and then only you can go for EC2. So to avoid that, AWS is creating a VPC in each and every region. If you go to any region, you will see a VPC is being created for us. Now, I created a VPC. Let's assume I created a VPC. Even if I create a VPC, AWS creates a default route table, which is basically main route table Folks, in exam, you will see the term as main route table only. They will not say default route table. They'll say main route table. AWS creates a default NACL. AWS creates a security group. Now, even if we create a VPC, AWS is creating these components. Let's understand logically why it is creating. Now, I created a VPC and I created subnets. I created subnets. Okay. Now, a subnet cannot exist without a route table. Now, after creating the subnets yesterday, we created 2 route tables. Now, let's assume you haven't created those route tables. So these subnets will go and associate under the main route table because without a route table, a subnet cannot exist. So as soon as you create a subnet, it will be under main route table by default. A subnet cannot exist without its firewall, which is NACL. An EC2 instance cannot exist without its firewall security group. So because there are dependencies, there are few components which are depending on these the other components or the default components which AWS creates. Or I can say, because these components, the subnets and EC2 instances are depending on the route table, NACL and security group, even if we create a VPC, AWS is creating these components. Because AWS created, they are called default components. You're following me? Hello? Any questions, please, so far?
No.
No.
Mm. So route table basically plays a major role in VPC, isn't it? We can make a subnet public, private, yeah, just by routing the traffic differently. Now we learned about main route table is the one which AWS creates, custom route table which we create. Okay. Now another aspect is um, I can have multiple subnets under one route table. I have a route table 1, I have subnet 1, I have subnet 2, I can have multiple subnets, not a problem. But a subnet can be under only one route table at a time. So let's assume I have another route table 2. I have subnet 3, I have subnet 4. Okay. Now, if I try to associate this subnet under this route table, this will get deassociated. And if I try to associate again, if I try to associate this subnet again under the route table 1, this will get deassociated. So you can have a subnet under only one route table at a time, either this or this. Because if you understand, if I have internet gateway, the subnets will become what? Public subnets. If I have NAT, the subnets will become what? Private subnets. Yeah. Now, if AWS is allowing a subnet under 2 route tables, how come a subnet can be public and private at the same time? Doesn't make any sense, right? So it is not allowing. So this how you remember, see, it's understand it, why it is not allowed. Okay. Internet gateway provides internet access for your VPC. It is highly redundant, horizontally scaled component. Means what? So there are millions of requests which are coming to the VPC. Let's assume. Now I have only one internet gateway. Will that be able to manage those many of requests, or do I need to have another internet gateway for the same VPC? Not required. Internet gateway is highly redundant and horizontal component, and mainly it is a component managed by AWS. Means there is no way an internet gateway failed. First point. There is no single point of failure for this. Means if you are working in AWS, you never hear a term called internet gateway failed. You will never hear that. It doesn't happen because AWS will be taking care of that component. And second thing is, even at millions of requests, the internet gateway can expand and shrink back automatically. The gate is managed. Okay. Now, can I have another internet gateway for the VPC? No, and it is not. It will not allow also. One internet gateway per VPC. One is enough. Good enough. This can be an interview questions. Sometimes, if you're going for basic certification, they will ask you this. Can I have multiple internet gateways for a VPC? Internet gateway will never be an issue. NAT, which allows internet access for the instance in the private subnet. You have two types of NAT, NAT instance, NAT gateway. Instance is the one which should be managed by the customer. Gateway is the one which will be managed by AWS. Next, we have VPC peering. Now I have two VPCs, VPC1, VPC2. Now I have an application in VPC1, database in VPC2. Okay. So this is a dev environment. This is test environment. Now, even though you have an application for dev and database, so you have application servers, database servers in both the environments, but you wanted to test the application which you developed in dev environment with the database in the test environment. Now, ideally, the VPCs are isolated. We learned that. You cannot see what is happening in one VPC from other VPC. It's a private network. But if you need to communicate within your components, between the VPCs, you can go for VPC peering. Explicitly, you have to establish this connection. If you go for VPC peering, these VPCs would interact, means the VPC components would interact with other VPC components as if they're in the same network. They work together as if they're in the same network. Okay, but in order to go for VPC peering, there are prerequisites. Okay. That these VPCs, CIDR should not overlap. For example, if VPC1 is having 10.0.0.0/16 and VPC2, assume that is also having same CIDR. Now, if you're trying to peer, please understand the set of IP addresses which you have in VPC1, you will have the same in VPC2 also because they have same CIDR. Now, if you need to work together, if these VPCs need to work together, how come, I mean, how you think is possible? Because if you take an EC2, okay, in this VPC, and if you take another EC2 in another VPC, if they have same IP addresses, like 35, 10.0.0.0, 35. Now, there is a possibility that their instance can have an IP address for one VPC and can also have the same IP address for another VPC. Now, if I need to reach this instance or this IP address, will it connect to this or this? Ambiguity, right? So in a class, I have 50 participants, okay, divided into two groups, and their roll numbers are 1 to 25. I have two groups with same roll numbers. Now, if I say call 1, there will be 2 people who would respond for that, isn't it? Ambiguity. So these VPCs should not overlap. See, they have different CIDR. So if they overlap, first of all, the establishment, the peering itself will be failed. It will not establish. But once it is established, there is no single point of failure. Okay. So a peering connection is established. Now, because we followed the prerequisites, whatever it is there. Now, peering connection is established. Now, can I go for a duplicate one or another one because what if it fails? No, there is no single point of failure for this. Once it is established, there is no failure. Okay. Now again, when you're going for VPC peering connection, the VPC 1 can be in region 1, North Virginia. The VPC 2 can be a region 2, for example, in Mumbai. The VPC 1 can be in my account. The VPC 2 can be in your account. So inter-region, inter-account is also supported. Now let's assume I have 3 VPCs, VPC 1, VPC 2, VPC 3. Now one can talk to 2. By having a peering connection. Now 2 need to talk to 3. So I have another peering connection. Now 1 can talk to 2 and vice versa. 2 can talk to 3 and vice versa. Now is it possible for the VPC 1 to talk to VPC 3 through VPC 2? It doesn't support transitive peering, means through a VPC it cannot reach another VPC. AWS doesn't support transitive peering. Okay. If 1 need to talk to 3, you have to have a peering connection between 1 and 3. Now, all VPCs can communicate with each other, isn't it? Now, what if I have 4 VPCs? VPC 1, 2, 3, 4. Now I want these VPCs to communicate with each other. Now I have to have a peering connection between 1 and 2, 1 and 3, 1 and 4, 2, 1, 2 and 3, 2 and 4, 3 and 1, 3 and 2, 3 and 4, and 4 and 1, 4 and 2, 4 and 3. Okay, now I have to have this many peering connections if I have 4 VPCs. What if I have 5 VPCs? 10, 50. You see the complexity it creates in order to create the peering connection between the VPCs. Okay, now whenever we go for VPC peering, you see there will be a record. The peering connection record will be added in the route table. Okay. So the number of records in the route tables would increase. Even in here you have it. So the number of records in the route tables would increase, isn't it? And the complexity. It is not that it is not possible, but it creates, the architecture would be too complex. In fact, there is a formula to find the number of VPC peering connections, which is n into n minus 1 by 2, where n is the number of VPCs. If I have 4 VPCs, 4 into 3, n minus 1 is 3 by 2, which is 6. So I need 6 peering connections if I have 4 VPCs. You see, 1, 2, 3, 4, 5, 6. 5, 6. Okay, like this, if I have more VPCs. So in order to solve that, if you have multiple VPCs, you can simply go for transit gateway. There is another component called transit gateway where you just add one record. Just add one record, okay, in the transit gateway for each VPC so that these VPCs would interact with each other using the transit gateway or through transit gateway. Okay, so it is private. And these VPCs can be in different regions also. Yeah. So if you have 2 VPCs, 3 VPCs, then you can go for peering connection. But if you have more VPCs, like 10, in fact, more than 3, it is recommended to use a transit gate. Now, what if you want to connect the cloud with the on premises or from on premises? One way is going through VPN. Folks, any questions? All okay? Any questions, please?
Uh, VPC peering is within region, right? Uh,
I said interregion also supported.
VPC peering. Okay.
Mm.
I confused in the transit gateway. It says inter-region. Got it. No problem.
Ah. Um, so if you want to connect from your on premises, there are a few things to remember here, okay? If you need to connect from your on premises to AWS, the customer should have a customer gateway. The AWS VPC should have a virtual private gateway. So a site-to-site VPN connection can be established. Customer gateway, virtual private gateway should be there. Okay. And this VPN is internet based. Even though you go for high-speed internet, you may not have consistency in the network. It's internet based. Okay. So if you wanted to interact with VPC, not much, like through 1 Gbps kind of links, yeah, you can use VPN. Okay. If you want to connect your VPC from multiple customer data centers, you can go for VPN Cloud Hub. VPN Cloud Hub. Okay. Again, the VPC should have a virtual private gateway and the customer should have a customer gateway and side-to-side VPN connection should be established. The beauty here is not only that they can communicate from VPC, from the data centers to VPC, they can also communicate with each other. For example, the data center 1 can talk to data center 3. The data center 1 can talk to data center 2. Now 2 can talk to 1 anyways. 2 can talk to 3. Now 3 can talk to 2, 3 can talk to 1. So apart from the strengthened link, you see this black line. Apart from the interaction from the VPC to the customer data centers, they can also communicate with each other. Okay. But whether you go for VPN or VPN Cloud Hub, they're internet based, as you could see. Now, what if you wanted to transfer huge amount of data? The interaction is so high that I need consistency. Then you can go for direct connect. You can go for direct connect. So if you go for direct connect, you will have a customer data center. You have AWS regions. And between, you will have a direct connect location. This is the physical location of AWS. This is a physical location. Okay. Where you will have a customer cage and AWS cage. AWS cage will have the AWS router, like the direct connect endpoint. And the customer cage will have the customer router. And these routers are connected using virtual LANs, VLANs, virtual LANs. Okay. Now from the AWS regions to the direct connect location and from the direct connect location to the customer network, these are the physical wires connected. It is not internet based anymore. The physical wires connected from the AWS regions to the customer data centers through direct connect location. So these are the physical cables. It's no more internet based. Now you have consistency in the network, not like the VPN. Okay. So if you want to transfer a huge amount of data, if you are interacting too much with the VPC, when I say too much, it's like you are going for each and every data you're trying to relying or you rely on AWS storage services or the components. And if you're looking for consistency, then you can go for direct connect. So direct connect is a physical location which has to be established. So it will take a time. It will take some time to establish. And direct connect is expensive. It's expensive. Okay. So what you can do is you can initially start with VPN. By the time direct connect is ready, then you can migrate it or you can change it. So VPN is because it's internet based, it doesn't take much time to establish. But direct connect takes time. So the customer has to wait for some time. Okay. So is there any way a direct connect fails? Yes, of course, definitely there is a way. So you can, as a backup, you can go for another direct connect also. Direct connect 1, 2, or this is 1. As a backup, you can go for 2. Or you can also have VPN as a backup. So you can have multiple direct connect, you can have multiple VPNs, you can have direct connect and VPN. Because there might be a chance that it fails. Because there are the physical cables connected. AWS cannot guarantee that. Okay. So what are the two ways where we can connect from on-premises to the cloud? VPN, direct connect. Okay. Yeah. Now, what if you want to interact with multiple VPCs from on-premises? You can have a transit gateway. Now a transit gateway can be used for communication between multiple VPCs. Now, instead of having a VPN or direct connected from on-prem to directly to one VPC, if you want to interact with multiple VPCs, then you can have a transit gateway, and transit gateway will have a connection to the customer gateway using VPN. Okay. You can also use direct connect. So from on-premises to transit gateway, you can have a direct connect. Okay. So to summarize, if two VPCs need to talk to each other, VPC peering. If multiple VPCs need to interact, you can go for transit gateway. Okay. Now, if a VPC need to be interacted from on-prem, VPN, direct connect. But if you want to interact with multiple VPCs from on-premises, VPN or direct connect to the transit gateway, not to the VPC directly. Now, through transit gateway, you can interact with multiple VPCs. Okay, we can extend our architecture basically. Clear so far? Any questions, please? VPC endpoint. High level architecture. I have a VPC, have a subnet, have an instance, routable, internet gateway. So VPC, subnet, instance, a routable, internet gateway. So public subnet, internet, and importantly, the VPC will be in a region. Now, let's assume I have an application on EC2. The application is generating media files. The application is generating media files. Now I want to store those files in S3 bucket. in S3 bucket. Now, ideally, whenever you are making a request, when application is making a request to S3 to store it, the request will leave the AWS network and store here. Okay. So basically, the request is actually leaving the AWS network. So the application request has to leave the AWS network. Through internet, it has to store to S3. Ideally, that's how it works. So if the customer wants the request not to leave the AWS network, so the EC2 and S3 are AWS services only. So for interaction between two, why the request has to leave the AWS network? Okay. So for that, what you can do is you can go for, for God's sake, VPC endpoints. VPC endpoint. As simple as that. That's it. So with the help of VPC endpoint, the request need not leave the AWS network. Okay. So the EC2 instance in a VPC can interact with other services within the AWS network. Now, in VPC, you have two types of endpoints. VPC gateway endpoint, interface endpoint. So gateway endpoint is if the EC2 instance need to talk to S3 or DynamoDB. Okay, if the EC2 instance need to interact with S3 or DynamoDB. DynamoDB is a database service. We will cover them later. Then you can go for gateway endpoint. Okay. But if EC2 need to interact with some other services, not, for example, Kinesis. Kinesis. Then we need VPC interface endpoint. So gateway endpoint supports only S3 and DynamoDB, whereas interface endpoint supports many more services. So that difference between two are just the number of services they cover. That's it. Okay. So Kinesis is also another AWS service. Okay. So gateway interface. Gateway supports S3 and DynamoDB, whereas interface endpoint supports many more services. Many more services. Any questions, please?
So the last part, I'm a bit confused, like in what scenarios we like the service request or a internet request go through S3, through internet. In what scenarios? I'm not getting that point.
If you have an application on EC2, okay, and see, the application is generating media files. See, for example, if you take MP3, MP4, The best way to store them is in the S3 bucket.
Yes.
Now, yes, there are scenarios where easy to need to talk to is S3. In that scenarios, what is your question?
My question, I'm not getting that point. Why a service request has to leave
That's how.
the VPC?
No, see, it needs to store to S3 means it's another service, isn't it?
Yes, but if it's in the same account or same region, so that's something I'm not getting it.
No, it was like that. By default, it will go through internet only.
Okay. Even if it's the same account or same region.
Doesn't matter. Doesn't matter.
Okay, okay. Even if you have two EC2 instances in same region, same account, they will communicate through internet gateway if it's a public subnet.
If they're in the same VPC, no, right? Yesterday we learned that.
Yes, so that's confusing me.
No, no, no. Okay. Got it. Now I understood what is confusing. Let me share my screen. So you see this VPC. Okay. If the VPC components need to talk to other services.
Oh, yeah. Now,
Yes.
yes, it's
Mm.
clear now. Yeah.
So that is the reason we call it as VPC endpoints.
Got it now.
Yeah.
So very common question, this is quite complex. The like transit gateway, site to site VPN. If I'm a new to AWS or new to the job, I hope this is not a straight away that you need to configure or this thing. I know it's a
Fortunately,
stupid question, but it's a bit complex.
ah, true, because we need to deal with the on-premises, uh, how it is the connection is established and all. See, fortunately, if you talk to anyone who is from networking background, okay, in order to
Mhm,
create a network, we just took a 1 hour session or 2 hours, okay,
mhm.
and then we configured the whole network, correct? But
Yes,
ideally, in on-premises, that's not the case. That's not the case. There are a lot of configurations which they need to understand before they create their network. It is
exactly.
humanly not possible to just understand in an hour. But fortunately, in AWS, they simplified it. They
Yes,
simplified the components creation and then associating them, attaching them, and all. So the same way, agree, completely agree when you talk with when compared with interacting with only VPC against multiple VPCs or even from on-prem to the cloud, the complexity would increase. Okay, but
yes.
but I can say that that is not too complex to understand. It is not too complex.
Mhm.
Probably you would be fine once you understand VPC and then okay going for VPC peering connections, how they interact. So step by step, if you could go, yes, that would be fine. That
Mhm.
would be easy also. Okay.
Got it.
Hmm. So the thing is like the either VPN or direct connect, by default they'll charge us because you straight away using a interaction, you're creating an interface between on-prem to the cloud,
Yes.
and even transit gateway will charge us when compared to VPC peering. So usually I expect this question. See, if we go for VPC peering, if we have more than three VPCs, then we can go for transit gateway. Okay, even for 2 VPCs or 3 VPCs, we can go for transit gateway. Simple one, right?
Yep.
Transit gateway is simple because you need not configure for each and every VPC individually. But why don't we go from the very beginning? Because transit gateway will cost us when compared to VPC peering. VPC peering is free basically. It is just that the CIDR should not overlap.
Mm-hmm.
Okay.
Yes.
Slowly, you will slowly understand until you are into this particular role.
Mm-hmm.
Okay, you may not understand. You may not learn also in this deep. But knowing at a higher level is good enough. Initially, yes. And over a period of time, you are, see, while you are working on it, you will learn a lot.
Mm-hmm.
I'm just explaining how it works, um, how can we integrate, etc. But there you actually see, okay, this is how it works, and you have a real-time scenario there.
Yes. So,
Mhm.
like looking at the diagrams, and it's easy to understand, but configuration is a different part. So,
Correct, correct. Definitely, it will be a challenge.
yeah. And the flow logs will be used for most of the time for the troubleshooting, I guess, if there
Um,
isn't a problem.
Correct, correct.
Mm-hmm.
So,
Correct.
Anupama, any security established for this flow logs and all? Because see, that is the point where there would be a possibility of any attack.
So, Ma, you're asking, is that security reason we are using flow log? That's what you're asking?
No, I'm asking like how we are protecting those flow logs and all. So any security allowed for that flow logs and all?
Definitely, Ma. See, we can protect the access to the AWS services directly. We will talk about it in the next session. Okay. So, for example, I can give access only to the EC2 for you, only to EC2. So, I can control the access to AWS services directly. So, yes, possible with the help of IAM. Mm. So, I think this will be answered next week clearly.
Okay.
Mm.
Because my area is security, cloud security. I
Oh,
would be more interested into that.
oh, okay, okay.
So, as we have a like flow logs or watchdog, do we have similar technology in other services as well to for logging the interaction?
Come again.
So we have this watchdog or flow logs,
CloudWatch.
CloudWatch, Cl- CloudWatch. Do we have similar thing in the other services as well?
Yeah, yeah, yeah. Oh my God, we have lot of services for logs. So CloudWatch, CloudTrail, VPC flow logs. These are all the services which we use to store the logs. Okay. Um, so flow VPC flow logs, which is very much relevant to VPC only. We learned that, right?
Yes.
Uh, few services uses CloudWatch logs or S3 to store the logs. Yeah. And when it comes to CloudWatch and CloudTrail, I think we have a slides on that. I will explain how this works, how this CloudWatch works, and why we use CloudTrail, why we use CloudWatch, etc.
Okay.
Okay, you have
Mhm.
uh, as far as I know, by default, usually customers uses S3 to store their logs because S3 is a service where it never run out of space.
Mostly S3 is like getting to Glacier. I have hardly seen.
Sorry, Anjali.
Yeah, S3 I have seen more. Glacier I have not even come across.
Glacier is for archival. Maybe if you could create a rule once and automatically it will move to archival. Okay. So will there be any lab for VPC peering? No. Um, yeah, I'll try to show you if you think it is fine. It doesn't take much time. But actually, VPC peering, we don't have any lab. If there is a lab, you might have seen there itself. Yeah, isn't it? Ideally, I don't like saying no to. So this is where I feel uncomfortable. I mean, definitely it's not your fault, yeah. So you can just say test peering, yeah. So you can select a VPC to peer with. So in my in North Virginia region, I already have a VPC. I can select it, and here you define whether you wanted to peer with a VPC which is in your account or in another account. So you can just keep as my account. If you keep another account, it will ask for account ID. And you wanted to peer for the VPC which is in this region or another region. Now, again, if you go for another region, it will ask what is the region. Okay. And then it is expected to give a VPC ID there and then create it. It's that simple. Okay. So as of now, I don't have any VPCs. I have only one VPC in this region, which is a default VPC. So test peering, select a default VPC. In my account, in the same region, select a custom VPC. Now they are not overlapping. They are of different CIDRs and I can create it. Now, because we are in the same region, I can see peering connection only here. Okay. Now, if I try to peer a VPC which of different region, I could see that this connection is being there in another region also. So for example, I'm in North Virginia as of now. If I go to Ohio, let's assume, if I try to peer with a VPC which is in Ohio region, I would be seeing a peering connection that it is trying to connect, that is trying to peer. Here also I'll record. But my peering connections, both VPs are in the same region. Okay. So I requested from a default VPC to the custom VPC acceptor. Now, because both are in the same region, acceptance also will happen from the same location. So I have to just go to actions and then say accept request. Now I'm doing from the custom VPC. I'm doing from the custom VPC. Okay. Now I can reject also. Now if I accept, active. Okay. MD. Yeah. It's deleted now. Now if I try to peer, anyways, I showing you. Let me show you one which it fails. Okay. Now if I try to create a peering connection, from the default VPC, another region, Ohio. Okay. Now acceptor VPC CIDR and requester VPC CIDR are same. Now if I try to create, you see by default is failed. Makes sense, right? There is no accepting or even rejecting. By default, it will not allow. Okay. Now, if I try to go for custom VPC here, this is a CIDR range of custom VPC, same account, another region, Ohio, Ohio VPC ID, if I'm not wrong. Yeah, and create. Now, because there are different CIDRs, initiating request, pending acceptance. Now I need to go to, now I'm in North Virginia region. Because my VPC in Ohio region, I have to go to Ohio region, go to peering connection, you will see a record here. Even the failed one also will be there. Yeah, I didn't show you, I think. So from here, I have to accept it. Okay. Because I initiated from this region, I can explicitly see requester VPC is custom VPC. Acceptor is this one. Because they are of different regions, I cannot see the tag. Okay. Now from here, request a VPC acceptance. Now I cannot see the tags here. Okay. Now I have to select explicitly this VPC, pending acceptance, actions, accept request. Provisioning, active, active, active. Okay. That's how even inter-region is supported. Yeah. Now if I try to delete the peering connection, it is deleted here also, because it's just one connection. Yes, got it.
So only requester who initiates the VPC peering can delete it, right?
That's a question.
Yes, I think so. Only if I'm creating it, I can delete it.
I'm not sure about that. Let's try. Usually I'll not show this hand sound. So, I mean, I'm not really sure about this. So I'm deleting from Ohio region. Deleted. Okay.
Mhm.
So now let's move to next topic. Route 53. Have an EC2, have an application on EC2 instance. We can access this application using IP address, public IP address like Apache. But ideally, in reality, we use domain name example.com, facebook.com, and we create the domain name in Route 53. So is it a domain name service? Yes. Is it like a GoDaddy? Yes. Okay. So there are three functionalities which Route 53 could do. Domain registration, routing, basically mapping with the IP address of the server, health check of the server, of the endpoint, health check. These are the three functionalities which Route 53 do. Simple topic. Okay. So Route 53, we can create a domain name for the, not only for the instances which are in the cloud, we can also create a domain name for the servers which are in on-prem also. It supports IPv6 and IPv4. Okay. It helps. So what this domain name service will do, it will allows to translate the domain name into numerical public IP address. Okay. Now it does three functionalities, as I said: domain registration, the routing, and health checking. Now let's understand usually how a traffic is routed to your website or web application. Now, if a user makes a request from a browser like facebook.com or example.com, the request will be sent to the DNS resolver. Okay. And this DNS resolver is responsible for getting the IP address mapped with this domain name, like something like this. If the IP address of this domain name is in the local cache, of the DNS resolver, it will be immediately returned to the browser. If it is not there in the local cache, if the IP address of this domain name is not in the local cache, then the next step which it will do is going to the DNS root name server. Guys, the process which I'm talking about is not just in Route 53. If you go for any website in the world, okay, the process would remain same. I'll tell you where it changes, okay? Now it will go to the DNS root name server. The DNS root name servers will have all the top level domain name server IP addresses or TLDs. What are top level domains? The .in, .org, .net, .com, .co.uk. You have hundreds of TLDs. Okay. Now the root name server will have all the TLDs name servers IP addresses. So each and every TLD, a top level domain, will have their own server. So the root name server will have all the TLDs name servers IP addresses. So whenever DNS root name server will receive a domain name, it extracts the top level domain and search for that particular top level domain, and it returns the .com TLD name server IP address. Then the DNS resolver will go and hit the .com name server. Okay. And this .com name server will have the details where the domain name got registered. Okay. So this example .com is registered in GoDaddy or in Route 53 or in Dynadot or in Namecheap. You have hundreds of domain name services which supports to create domain name in the market, right? Now it will have the details where it got registered. If it is registered in Route 53, the Route 53 name server IP address will be set to DNS resolver. Then the DNS resolver will go and hit the Route 53 name server. Now the Route 53 name server will have details of the IP addresses, which is if I have multiple IP addresses, based on the routing policy, I'll talk about what is routing policy, but based on the routing policy which we define, Route 53 randomly returns any one of the IP address to the DNS resolver. Then the DNS resolver will go and supply this IP address to the browser. Then the browser will hit the server, basically the EC2 instance, which has that IP address. Okay. Now the EC2 instance, for example, if it has Apache, now the EC2 instance will return that relevant web page to the browser. So when you give facebook.com for the first time in a new browser where you haven't browsed till now, it will do all this process to get the Facebook login page. And usually the whole process would take less than a second, isn't it? When you say facebook.com, is it taking minutes? You will never browse Facebook again, right? So, um, these are all theoretical topics. But anyways, so first of all, we can register domain name by searching here. Let's try to search facebook.com. I know it's already there, but let's see what it says. It's saying it's not available, but on top of it, it is giving suggestions. It's loading. Yeah. Now here I can say, I can select, okay, facebook.com is not there, but I have some name, something like this. So maybe easyfacebook.com is good enough. So I can simply select it. As you could see, it is showing $13, more than $1 per month. And I can simply click on proceed to checkout. And here I can enable auto renew, and I can also select how many years, for how many years I wanted to go for at a time, at a stretch. If you don't want it, you can disable this auto renew and you can go to next. And here you will give the contact information. Whether you are a person, you're registering as a person or a company or association or public body or a reseller, accordingly you will have certain options. If it is a company, you will have those relevant details. If you go for person, it will ask you the first name, last name, email, phone number, address, everything, PIN code. Okay. Now you provide all these details and then go to next, where you will go to review and submit. You just have to enable the terms and conditions and create a domain name. And your domain name will be ready in an hour. Okay. So that's how you can create a domain name. It's not something new. We know how to create a domain name usually, even in third-party websites. So very much similar in Route 53 also. Okay. Now, once we create a domain name, the next functionality is what? Routing. So in order to route, we create hosted zones in Route 53. So hosted zones are basically containers of records. The records will actually contain what kind of, how you want to route traffic. The records will have that information on how to route traffic. Okay. Now, when we say hosted zone, we have two types of hosted zones. One is public, other one is private. Public is the one you use public hosted zone if you wanted to access a domain name from internet, like a facebook.com or gmail.com or example.com. But if you wanted to access a domain name within the VPC, then you create a private hosted zone. Okay. If you want to access domain name from internet, public hosted zone. If you want to access from within the VPC, you create private hosted zone. So I have an application on an EC2 and you want to access the application from internet. Example.com. Now the application is having a database and a DB server. Now this whole thing will be in a VPC. Right? The application is accessible from internet. So this is for this domain name, I create public hosted zone. Now I can also create a domain name, which is basically called as db.com and map the instance, the DB server IP address. Okay. And in the application logic, I give db.com directly, not the IP address of the DB server for security reasons, just to mask the IP address of the database server. Now, whenever application need to touch or interact with database, it will hit the db.com. db.com will resolve into the IP address and it will hit the DB server. Now, you are accessing the db.com within the VPC. So, we create private hosters. Okay. Next, we have routing policies. Now, when you are creating a private, public or private hosted zones, okay, we can define how you want to route traffic. Oh my God, where is this? Oh yeah. You can define how you want to route traffic with the help of routing policies. Routing policies. Okay. Now, first comes with a simple routing policy. So let's assume you have a domain name. And you have, let's assume 2 IP addresses. So these are the instance IP addresses. Same application in 2 different instances. And you created a domain name from internet. Okay. Now in simple routing policy, whenever user tries to access a domain name, okay, Route 53 returns any one of the IP address to the user. Any one. Even if I have 10 records, it will return any one. And moreover, it will not check the health of the instance also. So because it is simple, as the name suggests, it randomly returns any one of the IP address and it will not check the health of the instances before it returns. Okay. Now, for some reason, if an EC2 instance is unhealthy, the Route 53 may return this IP address also to the user, where the user may... recording. So when an instance become unhealthy, the Route 53 may return an unhealthy instance IP address to the user also. Maybe the user will face the page not found error. Okay. So in simple, if you're going for simple routing policy, it's our responsibility to make sure the instances are healthy. Okay. Next, we have failover routing policy. In failover routing policy, by default, if I have two EC2 instances, I can design in such a way that by default, all the requests coming from the users will be routed to only one instance, only this instance all the time. If the instance fails, only if an instance fails, it automatically fail over to the next instance. So you'll have a kind of a backup. Better than simple. Okay. We also have latency-based routing policies. Let's assume when a user is trying to access this EC2 instance, the instance can respond in 75 milliseconds. Whereas this instance can respond in 100 milliseconds. The low latency instance IP address will be returned to the user. Now, maybe after 1 hour, now this instance is able to access, is reachable within 100 milliseconds, whereas the first instance is reachable in 175 milliseconds. The low latency instance IP address will be returned to the user. So at any point of time, it will make sure it checks the low latency instance and it returns that IP address to the user. Okay, that is latency based. Next, we have geolocation. So this geolocation routing policy would be used if you have your customers in different regions. Let's assume I have my customers in North Virginia as well as in Mumbai region. So obviously I will create an EC2 instance in North Virginia and another one is in Mumbai region. Okay. Now, if a user is accessing a domain name being in North Virginia region, the North Virginia region instance IP address will be returned to the user. But if he's accessing from Mumbai region, the Mumbai region instance IP address will be returned to the user. Now, what if a user is accessing from California region or Ohio region or any other region apart from North Virginia Mumbai? You will have a default one. You will have a default EC2 instance which you need to assign. It doesn't matter in which region it is there. It is basically marked as default. If a user is accessing not from North Virginia, not from Mumbai region, it will be sent to the default region. A default instance. So geolocation would be used if you have your customers in multiple regions. And if you wanted to serve the request, obviously, for the users within that region, right? We also have geoproximity. Geoproximity, I cannot explain in whiteboard. Just give a moment. 53 geoproximity, yeah. So geoproximity is basically whenever you define multiple regions, it will create the proximity by default according to the number of regions we define. So in this example, there are 5 regions. As soon as you give 5 regions, the location is being, the proximity means the boundaries is being divided automatically. Okay. Now I can control this proximity. For example, what does it mean is the users within this area will access the domain name or access the application from this region. The users within this area will access the application from this region and so on and so forth. Now I can control this proximity using bias. Now, for example, if you see this location 2, I can increase the proximity for region 2 by using bias, something like this. Now, if I am increasing the proximity for region 2, for example, it automatically reduces the proximity for other regions. If you see 1 and 3 before, okay, it reduced. Okay, so maybe if this instance in the region 2 can accommodate more users, you can increase the bias for that particular region. In fact, I can also decrease the proximity by using the bias again. So geo proximity is if you have users globally present. not one or two. Then what you can do is you can create a geo proximity, and then you can define the regions, and it creates the physical boundaries within the throughout the globe, and the users within that proximity will be accessible, will access the application from that particular region. Okay. We also have multi-value. Yeah. So multi-value is, I can compare this with simple. In simple, it returns any one of the IP addresses, even though if I have 10 instances IP addresses. But multi-value, as the name suggests, it will return multiple values. In fact, it will return 8 records. Of course, if you have more than then, okay. So it can up to, I can say, that is the best thing. It can return up to 8 records, whereas simple only 1. And not only it returns up to 8, it will return only healthy records. Whereas simple routing policy doesn't check the health also. Okay. Mm. Weighted routing policy. Let me give an example. Let's assume I have application in 2 different instances, and these instances have different instance types. This EC2 is of A1 medium, where it can handle medium number of requests. And another EC2 instance of M5 large, it can handle large number of requests, a bigger instance type, like a hardware configuration. Okay. Now, because I have instances with the same application with different instance type, with different hardware capacity, I can define the weightage by using weighted routing policy. I can say 30% of the request can be sent to this instance, and 70% of the request can be sent to this instance. If Route 53 receives 100 requests, 30 will be sent to this instance, 70 will be sent to this instance. It need not be 30-70, it can be 20-80, 10-90, 40-60, 50-50. By default, 50 will be there. So like that. Not only you can have 2 records, you can have multiple. You can define the weightage for multiple instances. Okay. So these are the different routing policies in Route 53. Simple, failover, latency, geolocation, geoproximity, multi-value, weighted routing. AWS may add more later also. Now the third functionality of Route 53 is health check. So Route 53 will make a request, expects a response. Expected response, and it responded healthy. Sent a request, it is not responding, unhealthy. Straightforward. Now, if you want to get notified, see, it is unhealthy, okay. But I wanted to know, the customers need to know. Now, with the help of Route 53, I can integrate with the CloudWatch by creating a CloudWatch alarm. Whenever, see, CloudWatch is a monitoring service, right? So if an instance become unhealthy, yes, it can detect and create an alarm where you can invoke it and another service called notification service, simple notification service. And then it will notify to the recipients or the customers. This is optional. 4.5 is optional. Okay. But ideally, Route 53 will just check the health, whether it is healthy or not healthy. We also have global accelerator. Let me just try to understand by directly going to the picture. Now, whenever users make a request to the AWS regions, the request will hop multiple networks. Because it is hopping multiple networks, there would be a risk introduced. And because it is crossing multiple networks, there is a delay. Performance issues also will be there while sending the request, while receiving also. Okay. But with the help of global accelerator, You will use AWS network, not multiple. You will use AWS network in order to reach AWS regions. Now there is only one network, performance improved. Because it's AWS network itself to access AWS services, risk reduced. There is no risk. Okay. So going back to the slide. So it improves the availability and performance of your applications, which are like local users for local users or global users. It would optimize the performance up to 60%. Okay. It will make sure that it's sent to healthy endpoints in less than 30 seconds. Okay. So it improves the application availability, accelerate your global applications, and easily manage the endpoint. So that's about the Route 53. Any questions, please?
No, I'm good.
So we'll go for a break. Post break, I'll start with database services. I'll show you the hands-on, and then also I will complete the slides, and the remaining time I'll give it for your hands-on, like guided practice. Okay, and we will wind up the call for today. Is it okay? Good. So I just open the timer. Happy break, folks. I7 back. The last topic for today is databases, or I can say last module. So we have a lot of database services, but we will be covering hands-on on only one service, and we will discuss the other service at a higher level. Okay, guys, you there? You didn't respond when I asked, "Are you back?"
Yes.
Okay, cool. Let me share my screen. RDS, a relational database service. Amazon Relational Database Service. RDS is a managed service. See, if I have a server, I can do whatever I can have or I can host whatever softwares I can have it on the EC2 instance, isn't it? I simply have a server. I can deploy an application, or I can have a containers, or I can have a databases. So on a server, I can do whatever I wanted. Okay. Now, if I have an EC2 instance to host my database, why I need to go for RDS? Why I need to go for AWS service, a database service which is RDS? Now let's understand. RDS is a managed service. Means if you need to deploy your database on EC2, first of all, you have to launch an EC2 instance with certain capacity, and you should be taking care of the volume which is relevant and required for, excuse me, for the database and the database itself. And you should be managing all. You should be managing the online server and then the enough storage as well as the database itself. You have to make sure everything is running. Now, if you go for RDS, you will have an EC2 instance. Instance will have a volume to take care of, to store the database data. And then you have a database here. But in RDS, you are responsible only for your database. You don't see on which operating system AWS is storing your data or creating a database. So because you don't have control over it. Managed. Few components are managed by AWS. That is the reason RDS is a managed service. Now, why I need to go for RDS over EC2? Simple. If you want to offload this overhead, you're responsible if you just wanted to manage your database, not the underlying servers, etc. Not only that, in RDS, you have a lot of options like automated backups are there. The replicas are being there. For high availability, your database can be replicated in multiple availabilities and automatically. Automatic failover is there. There are a lot of options where you can take advantage of using RDS over EC2. Okay. So usually, you would see in the world, you will see two types of data. Ideally at a higher level, structured and unstructured data. So structured is something where you can keep your data in rows and columns. Okay. Like student data or employee data. Each and every employee will have a first name, last name, role, payroll, designation, branch, department. Each and every employee will have such kind of details. Okay. Now, when it comes to unstructured data, you see this social media applications. The social media likes, comments, basic Instagram post. Okay. These all will come under unstructured data. Now, previously, before this big data, we have tools only to store structured data. That's where databases, the relational databases are the only way basically use it to store the structured data. And Anjali, you cannot annotate, okay? Yeah.
Yeah, please go.
So,
I will find it.
so I can't hear you. There's a lot of disturbance. You can use the chat. So, I'm talking about what? Yeah, structured and unstructured data. So before this big data, we have tools only to store structured data. Okay. Later, after this big data, there are lot of tools where they can analyze unstructured data. So previously, what we called as scrap data. Now there are tools to analyze it. That is the reason. If you observe, at some point, there are a lot of social media applications just emerged because at that time there are tools to analyze unstructured data as well. Okay. Anyways, even in AWS, there are a lot of database services for different scenarios, even though we are covering only few in this certification. But yes, if you could go to documentation or if you go to the AWS management console and go to databases category, you would see a set of database services. Yeah. So first comes with the relational database. Relational. So the term relational came because we can relate two tables. We can relate two tables and we can fetch data out of it. That is why it's called relational database. In AWS, we have RDS, we have Redshift. Usually, these relational database are used for traditional applications, ERP, CRM, and e-commerce, a normal application. Next, we have non-relational, also called as key value databases, where they are not structured. It is not expected to have a structured data here. You can have a random data. You can have as many as records, as many as columns. You have the flexibility in key value. Even though you store in tables only, but you have complete flexibility. We don't relate tables because the data is not in a structured form. So we don't relate it. So they're not non-relational, no SQL databases. In AWS, we have DynamoDB as an AWS offering. Next, we have cache databases. See, if you are accessing some set of data multiple times, the same query, if you are running the same query 100 times, it has to analyze that data 100 times in a database, right? Even you are using the same query, it has to does the same process in the database. Now the request cost would increase, and also the database has to go through all the same process 100 times. So what you can do is you can store that frequently accessed data in memory, cache. So we have cache databases. We have Redis and Memcache. So Redis and Memcache are the third-party database cache engines, which are supported in AWS in the form of Elastic Cache. So Elastic Cache for Redis, Elastic Cache for Memcache. Okay, so we explicitly need this Elastic Cache for caching, gaming leaderboards, and real-time analytics. First comes with the RDS. So we can create a database. I'll show you how to create a database also. Not a problem. So we can create a database. I'm talking about the database engine, not, we don't discuss about SQL queries here. We are trying to create a database engine itself or a DB server in order to store data in the form of tables. Okay. Now RDS is a transaction database, means you use RDS for inserting, updating, deleting the data. But you have another kind of database which is called data warehouse. So data warehouse is used for analysis or analytics. Okay. Now, if I wanted to know how my business is progressed over a period of time, you have to run some analysis on your data, right? So you actually does those analysis on a data warehouse. Whereas RDS is not an analytical database, it's a transactional database. Like you can use it directly for the applications. But in AWS, we have a service called Redshift that is for data warehouses. Data warehouse means their data warehouse will have historical data, means they will have data from many years from the very beginning, I can say. If the company, if the application has been running from 20 years, all the 20 years data will be there in the data warehouse. It has such kind of capacity and it is explicitly used for analysis. So RDS is a transactional database. Redshift is an analytical database. Now in RDS, we have different database engines supported. MySQL, MariaDB, PostgreSQL, Oracle, SQL Server. These are the third-party database engines. MySQL is not owned by AWS, right? It's supported by AWS. But we have Aurora. Aurora is a built-in RDS databases. So Aurora is an AWS database engine. It's an AWS database engine. Okay. We will talk explicitly about it as well. So if I go to RDS and if I go to databases and if I click on create database, so first of all, you have standard create and easy create. So standard create is basically where you will be selecting the options and then doing it. But easy create is something where the options have been selected automatically for you. For example, all the options are easily created for you. Everything is enabled yes or no, on basic settings. Okay, this is not what we are looking for. So we'll go for standard create. Now, when you say standard create, you have engine options. As I said, you have MySQL, MariaDB, PostgreSQL, Oracle Server, Oracle SQL Server, IB2. So IB2, IBM DB2 is being added very recently. This was not there last month. Okay, just few days back they added this IBM DB2. Okay, now AWS may add few more also. One second, please. So let me. Okay, looks like all the regions are supported that DB2, IBM DB2. Okay, cool. So IBM DB2 is very much recently added. Okay. So these are the third-party database engines which are supported by AWS. If you see, we have Aurora. So as I said, Aurora is AWS built-in. So in EC2, if you see, Amazon Linux is an AWS AMI. Remember? Amazon Linux. We used for NAT. The same way, that is AWS operating system. The same way, we have Aurora as an AWS built-in database, which is compatible with MySQL, PostgreSQL. That means if you're already using MySQL and if you're looking for greater performance beyond the MySQL capacity which it is already giving, if you're looking beyond that capacity, go for MySQL compatibility, which is Aurora. If you're using PostgreSQL already, and if you're looking for more throughput than the Postgre is already giving, go for Aurora Postgre compatible. So if you talk about mathematics, if MySQL is giving X performance or X throughput, the Aurora MySQL compatibility will give you 5x. If PostgreSQL is giving 5y throughput and Aurora PostgreSQL compatible will give you 3y throughput. Okay, and Aurora is very expensive. The way it creates it replicas and all, it's so huge and it is expensive to use Aurora. So unless you actually want greater performance and throughput, don't go for Aurora. And if you're looking for critical applications where you don't need a single second downtime, that data has to be replicated, availability is must, go for Aurora. Okay. For the demonstration, we'll go for MySQL. If you select, it will explain some about it. Okay. You can also define the versions. If you have a specific requirement, you can go for that version. Otherwise, go for the default one, which I'm doing it. Okay. Next, we have templates. Are you creating a database for production or DevOps or free tab? So accordingly, the options would be enabled or disabled. Obviously, we'll go for free tab. Okay. Because we should make sure that the options which we select doesn't charge us. Next, we have availability and durability. So by default, when you go for free tier, you can select a single DB instance. Means your database would be created only once. One single DB. In the service, and your application in EC2 can talk to the database. You can also go for multi-AZ DB instance, where your database would be replicated in multiple availability zones, multi-AZ. Okay, multiple availability zones, 1A, 1B, same database. Okay, the application will be talking to, this is a basically the primary database all the time, and it will have a standby connection. And this is primary connection, obviously. Okay, so the primary connection will be there to the primary database, and standby connection will be with the standby database. Okay, now if a database fails for some reason, if all of a sudden, if the primary goes down, the application will automatically fail over to the standby one, where this database will be promoted as primary, a new primary. Okay. Now, as soon as it becomes a primary, it will create another database as a standby one. Standby one. In another availability zone. So at any point of time, it will make sure it has two databases. And please understand that few things to understand here. Now, if a primary goes down, it automatically fail over. Means there is no manual intervention required. No manual intervention required. It automatically fail over to the secondary one or standby one. Now, when you have two multi-AZ, if you go for multi-AZ, these two databases are in sync. Whatever the data within here, within no time it will be here. So even if there is an automatic failover, the user who is accessing the data will not see any difference because they are of same data. Two databases having the same exact data, they are in sync. So the user will not see any difference in accessing the data. Okay, that is multi-AZ DB instance. You also have multi-AZ DB cluster. This is recently introduced. So in the multi-AZ DB cluster is basically more than two. So you have a primary database and you will have two standby databases. Primary, two standby. And also they are readable. So the primary is used to read and write. Okay. Now in the second scenario, which we just explained, which we just discussed, The standby is used for only for standby. That means it is not used for reads. But whereas this one in the cluster, you will have two readable standby databases. Means reads and writes anyways go to the primary one, but reads only can go to the standby ones. Okay. So again, when to use this? If you are not looking for reads, then you can go for multi-AZ DB instance. But if you want to also take advantage of the reads, because the database also can offload the reads to the primary database, right? It will offload. Otherwise, primary has to take care of read and write. Now, if you could offload reads, or if you want to, you go for multi-AZ DB cluster. But ultimately, DB cluster or DB instance both provides high availability. Now, if a primary fails, one of the readby will become the primary. One of the standby or readable will become the primary. And again, it will create another database, making sure that it has minimum of 3 again. Okay. So in the first, you'll have only one database. In the second, you'll have two databases minimum. Here, you'll have 3, in which you'll have read also here. So by default, the single DB instance is selected because I'm under the free tier. So, I mean, important things which we need to understand here is those. Other than that, we are good. We'll go with the default settings. This is giving a name. I can simply say my database. Okay. I can use hyphen here. Now, if you observe, I'm creating a DB server. Now, I should be able to have, I need to have a DB client in order to interact with the DB server, right? See, I created a DB server. I have to create a database. I have to create tables and insert rows, columns. In order to do all these operations, I need to have a client, right? Now we are actually creating the DB server. Now, in order to connect to the DB server from the client, we need to have what? Credentials. So the credentials can be defined here. Okay. So I'm just saying my credentials, defining my credentials, root, and I can define a password. Okay. You can allow AWS to generate a password, or you can use some other tool to get the password. And here comes with the instance class or instance type. So I'll go for T2 micro, which is under free tier. I'll go with the SSD volumes, which is GP2, and minimum is 20 GB. Maximum is 6,000. Under free tier, you can go for only 20 GB. Okay. But if you go for production workloads, if you go for production, the capacity would increase here. Okay. Now, minimum storage is 20 under free tier. You can also enable storage auto scaling. See, I started with 20 GB, but over a period of time, if my data is increasing, I want to automatically scale the storage, which you don't have in EBS yet. Manually, if you wanted to change, you want to manually change it. But here you have storage auto scaling where you automatically can scale your storage based on your data. Now, even though you go for auto scaling, you can define a threshold also. See, I want to start from 20. Okay. Now my data is increasing, and with my data, my capacity also I want to increase automatically, but only to 100 GB. I can afford only for 100 GB, not more than that. So you can define that way. So whether you enable storage auto scaling or don't enable doesn't matter. AWS is not going to charge you anyway. If you want to connect your EC2 instance with the database, you can connect to an EC2 instance and select it. Maybe you have an application, then you want to connect. Yes, but I don't want to connect, so I'll just keep it as don't connect. Okay. So I'll go with the default VPC. I'll not select any other VPC. I'll go with the default VPCs. I'll go with the default subnet group. Subnet group is a collection of subnets. It's a collection of subnets. Okay. So there's a default VPC and subnet group is already created. I'll go with the flow. I'll go with the default options. And if you want to access the database from internet, you can keep it as yes. If you don't want to actually keep it as no, I'm keeping it as yes because I want to connect to the database. And I can create a new security group because I don't have a security group for database. For database, the security group should have the 3306 photo. So I'm allowing the AWS to create a security group for me. I would name it as RDSDB. And I can allow in which availability zone I want to choose. Yeah. So with these options, if you want to go for monitoring, enhanced monitoring, you can go for CloudWatch. If you want to create a database while you're creating a database engine, for example, I can say test. Okay. If you want to automate the backups, you can enable the automated backups, which I'm explicitly disabling it because it will take a lot of time for me to create a database. If you want to create the logs for audits, errors, general logs, low query logs, enable them. If you want AWS to enable the minor version upgrades, to do the minor version upgrades, you can enable that. And deletion protection. If you don't want anyone to delete your database, you can enable the deletion protection. And you see, it is showing the cost. So DB instance and the storage cost. Okay. But you need not worry about this cost because it is showing if you are not under free tier. But our accounts are created very recently and we are under free tier, so there is no charge. Okay. So it's saying it is available for 12 months. You can use T2 micro. You can use 20 GB of volumes, 20 GB of automated backup storage support. Okay, so we are under free tier, so I can simply create a database with these options if it is not throwing any errors. Okay, so let it create. So multi-edge deployment is that basically. So you have an application, you have a primary connection to the primary database and standby connection to the standby database, and these two databases will be in sync. And they're in sync. Okay. Now read replicas are basically used to offload the reads to the primary database. So you'll have a read replica, you'll have a primary one. Primary will have read and write, whereas read replica supports only reads. Next, we have encryption. It's like this. I have an RDS and I enabled encryption for when creating it. So my RDS is encrypted. Okay. Now my RDS is encrypted. Now I cannot disable encryption for this RDS once it is enabled already. I cannot disable it. Encrypted is encrypted, that's it. The same way, I have RDS, this time which is unencrypted. Unencrypted. Now I cannot enable encryption for this RDS. Once it is disabled, I cannot enable it. But in this scenario, I have a way. There is a way where I can explicitly, for sure, for this database, I cannot enable encryption. But what I can do is I can take a snapshot, a backup. Now, because the RDS is unencrypted, the snapshot is also unencrypted. It is also unencrypted. Now I can copy the snapshot again. I can copy the snapshot again. Now, while I'm copying, I can enable encryption. While copying, I can enable the encryption. Now the snapshot is encrypted. Now create an RDS from the snapshot which is encrypted. Obviously, this also will be encrypted. Now you can just delete the unencrypted database and snapshot. Okay. So directly, definitely you cannot. Definitely you cannot encrypt the database, but there is a process which you need to go through. Okay. But in this scenario, there is no way where you can disable the encryption. No. Aurora. So as a database built-in one, it's a relational database service supported under RDS. It creates a 15 read replicas. So these are the replicas. It creates 15 up to 15 read replicas, excluding the primary. So including the primary, it will be 16. You will be having 16 databases, out of which 15 are read replicas. One is the primary one. This is the primary instance. The primary instance. So it of course, primary instances is supports read and write. Okay, whenever a read, a write has been happened, it will make sure it replicates in the data copies of the cluster volume. And using these data copies, the replicas would be updated at the backend. Okay, so it is 5x the throughput of MySQL, 3x the throughput of PostgreSQL. You can also go for Aurora serverless. See, if you remember in RDS, we defined T2 micro, the instance class, right? Now in Aurora serverless, you don't define any instance class. It's like a pay-as-you-go serverless model. According to your request, it will expand and shrink back automatically. You'll be paying for whatever you're using it. Serverless. Okay. Now, alternative to RDS. So just give me a moment. So alternative to RDS. When to use EC2 over RDS? Basically, if you want full control and flexibility, go for EC2. RDS is managed, no? The instance, you don't see the EC2 instance which is created in using when you're using RDS, the instance which AWS gives, you can't see it. You don't know where it is. You don't have key pair. You don't even see them. Okay. So if you want full control, go for EC2. But please remember, RDS is giving multi-AZ options, multi-AZ cluster, multi-AZ instance, automated backups, the read replicas, the patching, minor version upgrades, scaling, storage auto scaling. These features, obviously you don't get it when you go for EC2. So if you're going for EC2, you should be taking care of all those things manually done. You can go for EC2 if your database is not yet supported in RDS, like SAP HANA. Previously, there are only 5. Now AWS has added IBM DB2. And going to EC2 is a good option if it is not feasible to migrate to managed database. If it is not feasible, then yeah, go for EC2. Okay. So let's see. Our database should be ready now. It's in available state. Okay. Now, how do we connect? So what we will do, now we have an RDS. We have created a database engine. Now, in order to connect it to this database engine, basically engine or server, we say, we have to have a client. We have to have a client. In this scenario, the client is EC2 instance. Okay. Now, what we will do, we will launch an EC2 instance. Okay. We'll connect it to this EC2 instance. And from the EC2 instance, we'll try to access the RDS. Clear what we're going to do? Hello. So first of all, I'll go to EC2. Go to instances. Launch an instance. Okay. I would say DB client. I would name it as DB client. I'll go for Amazon Linux 1, Amazon Linux with send of filter, Amazon Linux 2. Okay. T2 micro. I need a key pair. So I will select the 17 December one. I'll go with the default VPC, default subnet. SH protocol is must. Stick with the root volume and I launch an instance. Let's see. Previously, the process is a little different. Now I modified it because we can use EC2 again to connect to an RDS, which is again an EC2 service. Okay. Now to connect it, I have to have a git bash. So just give me a second. Let me go to the folder where I have my key pairs. Okay. Now I can go to git bash here. Control plus ls. Now the December 6, 17 December should be there. I have it now. Okay. Now the commands can be little different, but ultimately the concept remains same. You can follow the instructions in the documents. So chmod 400, the PEM file, sh-i, the PEM file. Because it's not Ubuntu, it's an Amazon Linux. My username is EC2 user at the public IP address of the instance. So select the instance, take the public IP address, paste it, enter. Ideally, it should connect. Okay. Now, there are few things which you need to do. First of all, update it, sudo yum update. Okay. Now, next thing is you need to make this instance as NFS, sorry, not NFS, MySQL client. So because we are using a MySQL database engine, we have to make this instance as a MySQL client. Okay. So how? By running a command. So we say sudo yum install the MySQL client is MariaDB. MySQL client name is MarioDB. So confirm it that you want to install it completely. Okay. Now connect it. Now before you connect, now what you need to do is go to RDS. If you go to the database security group, okay. So AWS created a security group, but here it is given only custom IP address, that is my IP address. Now I need to go to anywhere and save it. Okay. Now I need to modify that in the security groups of RDS. Yeah. Now let's connect. So now this instance is having the instance has become a DB client. Now in order to connect it to the database, the command is MySQL -h means host. So who is the host here? The RDS. So you have to give RDS endpoint here. RDS endpoint here. Paste it. Okay. Space. -p, basically port, which is 3306. And -u, basically the user. Who is the user here? My root user. I have given the root as a credential. And -p for password. Now you have to just say -p and say enter. Then it asks for password. So here you have to give the password. So the password doesn't echo. It will not give any stars or so. You just have to type it and then say enter. Now it's successfully connected and now I am in MySQL. Okay. So when you are doing, you need to remember that here you have to keep capital P for port, small p for password. Okay. So here you need to remember your credentials. So while you are creating an RDS, you have to remember the credentials. Okay. So my credentials are root and I have given password. You have to remember that. Okay. Now I'm in MySQL. So I can say show databases first of all. So you remember I have created a database called test. Okay, let's create one database. Create database sys RDS DB. Sorry, create database only, what not s. Okay, now I created an RDS DB. Now let's run the previous command again and see whether the RDS DB is will be reflecting all around. You see, RDS DB is inserted. Okay, so that's how you can create tables, insert data. If you want to exit, I think exited, saying bye. Okay, so what we have done, we launched an instance first of all. We connected to this instance, installed the client. Okay, and then we connected to the RDS. Okay, understood? Any questions, please? So let me show you how to go for cleanup. So you just have to go to actions and then delete it. So while you are deleting an RDS, it's very important that you have to disable the final snapshot and acknowledge that you don't want any snapshots and type delete. So this is very important, folks. When you're explicitly deleting the RDS, you have to be a little careful. Otherwise, it will charge you. Okay. And you can simply terminate your instance. Yeah, so that's about the RDS. Next, we have DynamoDB. So DynamoDB is a NoSQL database. It's non-relational database. The concept is simple that you have a tables even in DynamoDB, but the data will not be in a structured form. Okay, DynamoDB supports millisecond response times. Okay, you'll have a millisecond, single-digit millisecond performance at any scale. See, DynamoDB supports unlimited storage first of all. So whatever it may be your storage, it supports it has a single-digit millisecond performance. Okay, so if you might be aware of Netflix, right? So Netflix is the #1 customer for AWS. Netflix uses DynamoDB. Like Samsung, they uses DynamoDB as well. So DynamoDB is serverless. Okay, so you can use DynamoDB for serverless web applications, microservices data store, mobile backends, gaming, IoT. Okay, now if you see the tables, so in DynamoDB tables, so these DynamoDB tables are first called as schemaless. What is schema? Schema is basically a structure. So RDS database are schema based, but DynamoDB are schemaless. You don't have any structure. And the only thing which you need to define when you're creating a tables is a primary key. So primary key is a combination of partition and sort key. Okay. So partition is mandate, sort key is optional. It is not mandate. But at least you have to have a partition key. Okay. Now the other attributes. So when we say attributes are basically the columns. If you see, these are the rows. These are the rows in DynamoDB are called data items. And these are the columns. In DynamoDB, we call attributes. So we can define attributes for each row differently. So we're talking about unstructured data, isn't it? So if you see here, for the first data item, you have 3 values. For the second data item, you have only 2 values, but they are not even relevant. For the third data item, there is again 1 value, 1 attribute only. So you can have unstructured way of attributes. You can have 1 attribute, 2 attributes, 10 attributes for each data item. So we have flexible, you can have flexible number of attributes for each data item. Okay. So in DynamoDB, we can define read and read consistency, in which you have eventual consistency and strong consistency. Means when you are reading data in DynamoDB, okay, you can define whether you wanted to have go for eventual, which is the default one, or strong consistent reads. So the difference is I have a data. I have some data. Whenever you store data, for example, A in DynamoDB, the data would be replicated in multiple copies. Now, when you update the data, it has to update in all the copies. Now, before it updates, if you try to retrieve it, before it updates in all copies, if you try to retrieve it, you may get old data. This is called eventual consistency. But if you are getting the updated data, it is called strong consistency. Okay. So you have to define whether you are looking for eventual consistency or strong consistency. Yeah. So the eventual and strong will be there when you are reading the data. If you're looking for accuracy, go for strong consistency. If you're looking for throughput, high throughput, go for eventual consistency. Now, in RDS, we define T2 micro, A1 medium, M5 large, M6 large, instance classes. But in DynamoDB, it's not like that. We define read and write capacity unit. Means one read capacity unit can read 4 KB of data item per second. Okay. If it is strong consistency, when you are reading, if you choose strong consistency, you can read 4 KB of data item per second. Otherwise, one read capacity unit can read 8 KB of data item per second. And if you choose eventual consistency. So the number of read capacity units depends upon what is the data item, how much is the data item size, and whether you are looking for strong or eventual consistency. Okay. Now this is when you're reading it. But when you're writing, this is directly proportional. One write capacity unit can write 1 KB of data item per second. If you want to write 40 KB of data item per second, you need 40 write capacity units. Okay. So basic architecture or simple use case. You have a static website in S3. Now, whenever users clicks on the weather application, it will be sent to an API gateway where it will manage the APIs. And the request will be sent to the Lambda function. Lambda will get the data from the DynamoDB because DynamoDB will have all the information related to the weather. Okay. Now, important feature in DynamoDB is the global tables. So DynamoDB can have its tables replicated in multiple regions, Europe, America, Asia, so that wherever the user can be, in whichever location in the world can be, they can access the data with low latency. And these replicas can be updated, you see, in real time. Okay. So these replicas will have the same table name and the same schema. Okay. Now, if a user writes into one database or one replica, it is replicated in all other replicas. So DynamoDB supports global tables. The table can be automatically replicated in multiple regions. We have DynamoDB accelerator also. So if DynamoDB is giving X performance, DynamoDB accelerator will give you 10X performance. If DynamoDB is giving millisecond response times, DynamoDB accelerator will give you microsecond response times. Okay. So you will have microsecond response times even at millions of requests per second. Internally, DynamoDB uses elastic cache. They use a cache cluster, okay, to improve the performance up to 10 times. So in the exam, if you see 10x performance, milli to micro, if you see these terms, DynamoDB accelerator is the answer. Okay, I've seen this in the exam. That is the reason I have added as a slide. And finally, we have elastic cache. So elastic cache is used for caching. So let me simply explain about this. I have an application, have a database. And whenever users makes a request, it has to hit the database. The database will do some sort of process. Now, if a user is trying to make a request multiple times, the same request multiple times, the database has to go through all the process every time. That's where elastic cache is introduced. Now you have elastic cache here with the application. Now, whenever users makes a request, so user is requesting for data A. Now, because the elastic cache is just enabled, whenever application makes a request to the cache for this data, there will be no data in the elastic cache. That's basically cache miss. Okay. So the application don't get data from elastic cache, go to the database, get the data, store it in the elastic cache, will be retrieved to the user. Now this happens for the first request. But from second request till nth request, the same user or any user who accesses the data A it will be immediately retrieved from the elastic cache. So now for the second time when use application is hit in the elastic cache, the data will be there. So it's a cache hit. It's a cache hit. So the data will be the application will get from the elastic cache, retrieve it to the user. Now this is basically called as lazy loading. This strategy, the caching strategy is called lazy loading. Now in lazy loading, there will be cache miss for the very first request every time. Now request will cost us. So for cache miss means basically you're making an empty request. You are simply getting charged for making a request. So what you can do is you can go for another strategy if you want to avoid this, which is write through. Write through is another strategy where you have an application, you have a database, and you'll have a cache, elastic cache, for example. Now, whenever a data is being inserted, it's not about accessing it. Whenever a data is being inserted into the database, the application will not only insert in the database, it will also insert in the cache. That is write through. Now the data is in the cache as well as in the database. So whenever users makes a request to the data, it will be getting from the elastic cache directly. So there will be a cache hit all the time. But in write through, you have to have some sort of strategies to empty the cache, like not accessed much, delete it. If a data is been older than 15 days or 1 month, delete it. So you have to make sure you have some strategies to empty the cache to accommodate more and more space. Because whatever the data which you have in database, if you have in the cache would be full all the time. So you can define some strategies to empty the cache, like as I said, the least accessed, not accessed for 15 days or something like that. Okay. So this is how usually the database cache works. Anywhere, not just in AWS. So AWS Elastic Cache is a fully managed Redis and Memcache compatible service. It provides high availability, good performance because the database need to not go to the whole process again and again. It saves the cost to the database, hits to the database would reduce, the burden on the database will reduce, and Elastic Cache can be integrated with multiple services. Okay. Now we understood about the lazy loading strategy and write through also. It's done. Now Elastic Cache supports two types, Memcache, Redis. Yeah. Now, even though both are cache engines, Memcache is used for simplicity. For simple applications, you can go for Memcache. But for complex applications, go for Redis. If you are looking for rich features, go for Redis. Okay. Now, you need to understand the difference between Memcache and Redis to, select the right one for your use case. Okay. Now, let's understand a few differences. Now, sub-millisecond latency. Both Redis and Memcache will provide sub-millisecond response times, means good performance. Data partitioning, both Redis and Memcache allow you to distribute your data among multiple nodes, both. Advanced data structures, only Redis support advanced data structures like lists, sets, sorted sets, hashes, bit arrays, hyperlocks, etc. Multi-threaded architecture, only Memcache supports multi-threaded architecture, where it uses multiple cores for compute. Snapshots, only Redis supports snapshots. Replication, only Redis supports replication. It will replicate multiple copies for high availability. PubSub, publishing, subscribing, only Redis supports PubSub. So when it compares, there are few features. These are the few features. Okay, when compared to Memcache, Redis has more features. Okay. And finally, we have database migration service. So we are talking about databases. So database migration. If you want to migrate from on-prem to the cloud, you can use database migration service. So you'll have a source endpoint, the database endpoint, the target endpoint, and replication task. So where it replicates, start replicating. Okay. So you have a homogeneous replication, heterogeneous replication. Means you have your Oracle. You want to migrate to Oracle. Same. Homogeneous, Oracle to Oracle. You have Oracle here, but you want to use MySQL. Heterogeneous. So while you are migrating, you can also change your schema. Now, if you're going for heterogeneous migrations, you have to have a schema conversion tool addition to this replication instance. Schema conversion tool, where it will convert the schema from Oracle to MySQL. If you want to go for heterogeneous, then yes, schema conversion tool should be used. Okay. So it is simple to use, minimal downtime, supports wide list databases, low cost, fast and easy to set up and reliable. Okay. So that's about the database migration service and the database service at all. So RDS, relational, DynamoDB, non-relational, Elastic Cache for caching, and database migration service for migrating the database from on-prem to the cloud. Okay. Any questions, please?
So Redis and Memcache is for high availability, right? Database
For the
high
performance, not for availability,
performance.
performance.
Performance. Okay.
Yeah. So every time, see, it's like this. Let's assume I'm the application, you are the database. Whenever I wanted to have some data, I will be asking you and you will be giving the data. Okay. Now, if you need to give the data, you have to do a lot of operations. You have to churn the data, and then you have to get the data, the database and get the data. Now, if we have a mediator in between, where you can say to that mediator that, see, whenever she asks a similar kind of data, you give this kind of data. I mean, you provide that. So whenever I am asking, I don't ask you directly. First of all, I'll ask the mediator if you have the data. Okay. Now, if I already ask this kind of data, it will be retrieved from the mediator itself. If it is a new data, then the mediator will ask you. So cache is like a mediator between application database to improve the performance. So every time I need not hit you. You might be doing a lot of operations like inserts, deletes, updates to the database. Getting me, Ashish?
Yes, yes, Anu.
Mm. Any other questions, please? Okay. So please start doing the RDS part. Create an RDS, create an EC2 instance, and connect to the instance, and from the instance to database. Okay. And let me know if you're facing any challenges. Once it is done, yes, you're good to leave. I'll not be covering any other topics, even if we have time, because we covered a lot of topics. It can be so overwhelming for you.
It is actually very theoretical.
Yes, correct. That's right. Okay. So I'm just opening the rooms. Please complete it.
Anupama, we are done. So,
Do the cleanup and you're good
Question.
to leave.
Yeah,
okay.
Anupama, that question, like when we have created one test database.
Ah, okay.
So, like, how exactly? What is the significance of that? We have
No, ma, just to
creating.
see, we can create a database after creating RDS or while creating RDS.
Okay, okay,
That's it.
that's
Nothing
it, no?
significant.
Okay, yeah, that's it.
Guys, when you are deleting the database, make sure you disable the final snapshots. Manual snapshot or final snapshot, whatever the name it is.
Yes.
Yeah.
Yes.
Hmm.
So that option will be enabled if we enable the backup, right? Because we don't get that option. We
No,
didn't
no,
get
no,
that.
no, no. Automated backups are different. Manual backups are different. Automated is the one which AWS creates. Now, while deleting the RDS, the one which you are disabling is manual one.
Mhm.
Mm.
So it's under snapshots, right? Can I share my
When
screen?
we will configuring, Ashish, that time we untick that part. Enable backup, I guess.
Correct. While you are deleting it, I'm talking about it, Ashish, not.
Mm. So if we enable, then only we get that option.
I said no, yaar. What I am saying, when
Hmm.
you say, when you enable, you're enabling automated. That is different. Now, while deleting,
Mhm.
it's a manual one. Automated means if you,
Yes.
while creating RDS, if
Hmm.
you enable automated backups, AWS automatically will create a backup for your RDS. Automatically, every day it will create. Okay. Now,
Mhm.
manual one is while you are deleting. While you are deleting your RDS, AWS enables you to create an manual snapshot.
Okay.
So while you are deleting RDS, you have to disable the manual snapshot.
Yes.
Mm, thanks.
So we can leave for the data, Anupama, right?
Yes, Anjali.
Yeah. So I wish you a very happy New Year in advance.
Hey, Happy New Year. Happy New Year.
Yes. Right.
Yeah. Happy New Year, folks. And have a great week ahead. Yeah. See you the next week. Bye bye.